Hey everybody, it's Max again, gonna work on this problem 5-78. It's not like it was a homework problem, so I'd like to help out a little bit. One of the main things, I put the answers here below just to kind of show you, just make sure we're doing it right, but one of the things to look at here is you got this bent up rod and it has 3 journal bearings. So the main thing to know about the journal bearings is that they're only going to have reactions either like on the surface they're mounted to, either up and down or side to side. So the rod can slide through this way, and then they're kind of like a spherical joint where none of them provide any resistance to moment. So that's kind of the main things. That's why it says kind of at the end here, the bearings are in proper alignment and exert only force reactions on the rod. So what they're basically saying is that, like, if the rod was bent up and you put it in there, there'd just be some forces from the rod being like deflected. So that's why it's saying they're all aligned, and so you're good there. So first thing to look at is, like, what are our reaction forces? Which ones do we need? So if we look at A, for example, it's only going to have a reaction in the x direction and the y direction. So we're going to have to find AX, AY. And then for B, it's in the x direction and in the z direction. It can slide in the y direction. So we have BX and BZ. And then for C, you have it in the y and the z, and it can slide in the x direction. So CY and CZ. So first thing I'm going to do is look at the force vectors and get them into their component form. So let's look at F1 first. Okay, magnitude is 300 pounds. And then that's going to be, so and it says here it's in the YZ plane, so it means there's nothing in the I direction, in the X direction. And then in the Y direction, it's minus cosine 45, so that's minus, got that wrong already, minus 1 over square root of 2j. And then in the z, it's in the negative z, so minus 1 over square root of 2. Okay, so that's cosine 45 and sine 45. And if you want to keep your units good, pound force at the end. Alright, then F2. Hopefully you kind of are understanding how they draw this thing here. So what they're saying here is that if you project F2 into the XY plane, it's along this line here, which is so it's 45 degrees projected into the plane and then 30 degrees projected to Y. So for the X value, you got to project into the plane, so you get cosine of 45, and then to X is sine 30, and then for the Y you got cosine 45, cosine 30, and then so those are both positive, and then in the Z it's minus Z sine 45. So minus. So if you do those, you get 1 over, so square root of 2, 2 square root of 2i, plus, so you have 1 over square root of 2 from that, and then square root of 3 over 2 for that, j, and then minus 1 over square root of 2. Okay, I'm just going to keep all the math, or keep everything in this form. And then just do the conversion, just decimal at the end. Alright, so we have our reactions, we have our forces, so we'll get our, so one thing to remember, we got 6 unknowns here. Sorry, dog's going crazy. So 6 unknowns, and we have to have 6 equations. We'll get 3 force, summing the forces up in the 3-axis, and then we'll do a moment reaction around some point, and that'll give us 3 more, because it'll be XYZ for that. Alright, so let's just first sum up force in the X, get 0, so just kind of go through here. We got AX and BX, and then that's just 250 over 2 square root of 2, and that equals 0. And we sum up the F and the Y, that equals 0. So we have AY, and then plus CY, and then in the Y we have minus 300 over square root of 2, and plus 250 square root of 3 over 2 square root of 2. And then sum up the forces in the Z. Same thing, we got BZ plus CZ, and then minus 300 over square root of 2, and then minus 250 square root of 2. Alright, so that gets us 3 equations with these unknowns. Now we gotta pick somewhere and sum the moment up, and this is where this problem gets interesting, because we have 3D vectors, so it kind of becomes a pain. I am going to just pick A and sum up. It just gets rid of the AX and AY, so those, since those pass through there, we won't have to do those, but then we got to deal with the rest of the mess. So sum of the moment around A, and I'm going to use cross product for this because there's no way I could keep track of these otherwise. So we're going to have some vector from A to, I'll go call it R, from A to 1, and that's just from A to where force 1 is applied. So it's going to be cross multiplied by force 1, and then the next reactions are going to come from B, so we'll have a vector from R from A to B cross the I could write it just FB, whatever. That's just basically the vector that's going to be made up of BX and BZ. Go one by one. Next one will be at point 2, so we'll call it R A to 2 and force 2. And the last one will be at C, so R A to C cross multiplied by the force at C. Alright, so now we got to get all of these in given vector form, right? So let's go through. So we got 0 and then equals to, so what's the vector from A to 1? So to go from A to 1, all it's going is up 1 in the Z direction. So I'm going to write them all out, what the heck, just so that when we do the cross multiplication it's easier. So 0I plus 0j plus k cross multiplied with F1, and that's just what we have up here. So it's 0I minus 300 over square root j minus 300 over square root of 2k Okay, plus the next one from R from A to B. It's, if we go, it's minus 4 in the Z, and then plus 2 in the Y. So 0I, and then plus 2J, and then minus 4 in the K. Okay, and then that's for BX and B, or B only has BX and BZ, so B, and we just defined them in the positive direction. Just, you can deal with it later. So BX in the I plus 0 in the J plus BZ in the K. Okay, let's go on the next line. RA to 2, so from going from A to 2, it's similar. We go down 4 in the Z, but then plus 5 in the Y and 0 in the X. So again, we get 0I plus 2, plus 5J minus 4K. And then the force 2, so we get 250 over 2 square root 2 I plus 250 square root 3 over 2 square root 2, just having what we have up here in the J, and then minus 250 over square root 2 in the K. And then the last one is from A to C. So to go from A to C, this one has an X in it, so it's minus 5 in the X, plus 5 in the Y, and minus 4 in the K. So minus 5I plus 5J minus 4K, and then this is cross product with FC, and FC just has a Y and Z term, so 0I plus CYJ and plus CZK. Alright, so move this up. Alright, so now what we got to do is cross multiply 4 times. So I don't know, this is how I do it. You guys probably have your own methods here, but I'll show you what I do. So because I try to have like a little algorithm in my head that makes it so I don't have to remember all the pluses and minuses that much. So first one we get 0, 0, 1, and then 0 minus 300 over square root of 2, and minus 300 over square root of 2. So it's the first one. Next one. I should be hats. Get a cold. Hat. Alright. So 0, 2 minus 4. And then here bx 0 bz plus 0 5 minus 4, and just divide that out. So 250 divided by 2, so 125 divided by square root of 2, same there. 125 square root of 3 over square root of 2, and then minus 250 square root of 2. And you can feel free, if you're doing this, to just find the decimal value of that and keep track of it. I always do this in hopes that the radicals will drop out, cancel out some. I don't think they are in this problem, but there's always a hope they cancel out, and that makes you happy. Alright, and then the last one, minus 5 minus 4, 0, cy, cz. Alright, it's not a fun part, doing the cross multiplication. So, I'm sure you guys have a way to do it. This is how I do it. I think of it's, you multiply, you start with your I value, and you're going to multiply this way, and then subtract, because that's, I think of that as kind of going forward, and then going backwards this way, you wrap around to this value. So I go like that, and then wrap around. So in this case, you get 0 here, and then going backwards minus 1 minus that, so you get a plus 300 over square root of 2i. And then for the j, positive, going this way, that's a 0, minus 0, so there's no, I'll just write it in. You don't need to write it in. It's a 0. But it's okay. Going down this way, gotta wrap around 0, 0, and then back 0, 0, so 0k as well. So I, going forward, get 2 bz, and then going backward will be minus 4, but 0, so that's all it is in the I. And the j, going forward, minus 4 bx, I should have checked to make sure, but there's 0 that way, so it is 0. And then k, going forward, 0, 0, and minus this way, so minus 2 bx. J here, minus 2 bx, k. Okay, next one, I, so positive this and this, minus that way, so this one we get minus 5 times 250 over square root of 2, and then minus, so that's a plus, so it's this whole thing is I. And then for j, it's minus that, and then going backwards to 0, so minus 4 times that, times 125 over square root of 2, that's the j. And then k, going forwards is 0, going backwards is that, so it's a minus 5 times 125 over square root of 2k, and fortunately you gotta go to the next line over here. So I is 5cz, and then backwards is minus, but it's minus minus, so plus 4cy. Terrible 4, sorry about that. It's the I. J, minus 4 times 0, 0, and this is a minus, so minus 5cz. Oh, it's in the minus, so it's a plus 5cz. K. And J. I said J, right? Or did I say K? It's J. And then K. So minus 5 cy, and then this way it's 0. So minus 5 cy in the k direction. And that equals 0. Like there's 0 vector, so 0, 0, 0, right? Alright, so from all this mess now, sum up, we can get 3 equations. We sum up all of our I terms to get to 0, all of our j's and all of our k's. So let's go through it. We get, so if you want to, let's just call it sum of max equals 0 equals 300 over square root of 2 plus 2 bz minus 5 times that, 1250. Let's hope my math doesn't screw me up here. Over square root of 2 plus, so that's 500. I said I can't do math in my head, but some math I can do if it's easy enough. Psi, and then plus 5cz plus 4cy. And that's all equal to 0, so that's net. Sum m-a-y equals 0. So do the y's, you got 0 here. Got minus 4 bx minus 4 times that, so that's 500 over square root of 2, and j is plus 5cz, and finally m moment around a in the z direction equals 0. Here we get 0, we get minus 2bx minus, I lied, was that, so 625 over square root of 2, and then minus 5cy. Alright, so now we got 6 equations, right? Not going to be able to fit them probably all in paper. Well, there we go, we can barely do it. So, we have these 3 equations and these 3 equations. So, I'm going to rewrite them. Let's see if I can do this somewhat cleanly. So what I want to do is write them in a form where we have the variables on the left hand side and equals the constant on that side. So we'll rewrite the first one, ax plus b x is equal minus, minus 125 over square root of 2. This next one we got ay plus cy, that's equal to sign changes, so you get 300 over square root of 2 minus 125 square root of 3 over square root of 2, and then the last one we get bz plus cz, sorry if my z's look like 2's, that's annoying, equals 300 over square root of 2 plus 250 over square root of 2, so that really is what, 550 over square root of 2. Alright, and then let's move these guys up. So get that one, so we'll get 2bz plus 5cz plus 4cy is equal to, so put that on the other side, 1250 over square root of 2 minus 300 over square root of 2 minus 500 square root of 3 over square root of 2. So 1250 under, they got 950 over square root of 2 minus 500 square root of 3 over square root of 2. And then this one we'll get minus 4 bx plus 5cz is equal to 500 over square root of 2, and then minus 2bx minus 5cy equals 625 divided by square root of 2. So now you can go and solve these just by substitution. You know, you can start with, I'd probably let's look and see what we got here. I'd probably start by solving both of these for bx, and you can find cz in terms of cy and bz in terms of cz, plug them in here, and then solve for cy or cz. That's pretty, it takes time, you know, not a big deal, but pretty straightforward to do it that way. But I kind of wanted to also take this time, I'm going to show you a way that, like, if you when you're professional, like how you would solve something like this, because you get in situations where, you know, you have a structure with dozens or hundreds of unknowns, and you got to figure it out, and there's just no way you're doing it like that. So the way we do this is we use matrix math. So I'm sure you've kind of seen this before, but this is like a good application for it. So I'm gonna kind of go back. So what this really is you can find you can create a matrix A, and what it is it's a matrix that has the size of the number of unknowns. It's a square. So in this case you would have a 6 by 6 matrix. We've got 6 unknowns, so 6 rows, 6 columns, and then times your unknown, like your vectors, ax, so a times x, and that's going to be equal to your b vector, which is all this stuff on the right hand side. So you'll have 6 rows in each of these that represent the values from all your equations. So let's look at this. Probably get myself in trouble. Let me just make it really big here. Move it up a little bit. Let's hope I don't. Alright. Well, that'll be our A. That'll be our X. And that'll be our B. And so you notice that these two are columns square. And so that'll be 6 by 6, that's 6 by 1, 6 by 1. Alright, and so the reason we do this now is that we can put it into a computer. So I'll probably be showing you Python, NumPy, because it's free, but MATLAB is pretty much designed to do this. So if you have MATLAB, you can do this. But what you end up doing then is you want to solve for the inverse of this matrix. So you'll solve for a minus 1, and then you multiply both sides by that, and you'll get so if you pre-multiply both sides by a to the minus 1, those become the identity. So you're just left with x, a, man, I shouldn't have squeezed it in there, but inverse of a times b, and that gives you your answer. You'll just have what all your values in x. So in here, for example, here we'll fill this with all of our unknowns. So we have ax, ay, bx, bz, cy, cz. And so if you remember your multiplication, matrix multiplication, it's like this times this, plus this times this, plus this times this. So the row here will be what our first equation is. So if we go through the first row, what do we get? We have ax is 1, ay is 0. I'll try to make this so I don't run out of room. Bx is 1, bz is 0, cy is 0, cz is 0. So that's the first equation. Second equation, ax is 0, ay is 1, bx and bz are 0, cy is 1, cz is 0. Third equation. So bz is the first term, so the first 3 are 0. And then we have bz is 1, cy is 0, cz is 1. Okay, next one we have bz, so first 3 again. These are 0, bz is 2, cy is 4, cz is 5. Next one, first 2 are 0, bx is minus 4, BZ is 0, CY is 0, CZ is 5, and then going across again, first two are 0, BX is minus 2, BZ is 0, CY is minus 5, and CZ is 0. And then so here, probably should have made it wider, but let's go through it. So this is just going down the right hand side of these. So first row is minus 125 square root of 2. Second row is 300 square root of 2 minus 125 square root of 3 over 2. Third row, 550 over square root of 2. 950 over square root of 2 minus 500 square root of 3 over square root of 2. 500 over square root of 2, and 625 over square root of 2. Alright, so I'm going to switch over to programming. There's an online programming NumPy that you can use. It's online, it's free, it's really super easy, and I'm going to show you how to solve that. Also, if you feel like it, man, I wouldn't want to do it, but I don't know if you remember like the elementary row operations that you can do where you can like subtract one row from another or add multiples of it to try to get this into an identity matrix. So you take this and put an identity matrix next to it and do all those operations. You could do that if it's like 3 or 4 maybe, but on a 6x6 I wouldn't do it. I'd probably make a mistake. So if I was doing this by hand, I would do the substitutions for all of these. That's pretty straightforward. Just takes your time, but I'll show you how to do this, the matrix one on the computer. See you in a sec. So here's the program I was talking about. You just go to onlinepython.com, and it's a free Python environment. If you're familiar with it, but you really they pop this up just as like a demo, but I'm not going to use that. So Python's similar to similar to most programming languages. It's super clean, and then they have an extension, or I don't know what they call it, but it's called NumPy, and it's kind of like a free version of MATLAB. Not as clean, but hey, it's free. So you can do the same stuff with MATLAB. So the first thing you have to do is import NumPy, and you have to just import it as some. I'm not a programmer really, so but you give it a variable, so that kind of gives you access to all of the routines in there, the matrix routines. So first thing we want to do, so if you have a printout of the big matrix we made before, this is what we want to do. We want to create that big A matrix. So you do that by calling NumPy array, and you give it a. It's a structure that you use the square brackets for. So a square bracket goes around the whole thing, and then there's commas in between the elements. So the way we'll do is so each row gets its own bracket. So I'll just go through this and put the constants from that A. So first one was 1, 0, 1, 0, 0, 0. And then hit a comma after that. I'll just tab over so that we're just aligned. So the next one was 0, 1, 0, 0, 1, 0. So that's the second. What's this? Next one, 1. Next row is 0, 0, 0, 1. 1. Comma for the next row. 0, 0, 0. And then it was 2, 4, 5. And a comma. 0,
0, -4, now all the rows are messed up. That's alright. 0, 0, 5, and didn't mess anything up. Comma 0, this was -2, 0, -5, 0, and so that should create the matrix. And Python's really nice as far as printing. You don't have, it's not like C where you got to cast a whole bunch of stuff around. So this we can just say print A. Well, actually, it should actually run. Let's see. So we'll look at A. All right. So you just check, and it kind of does a nice justification. It actually lines everything up. It's a good job. So you just check, make sure we didn't mess up. 0, 1, 0, 1. That's 2, 5, 0. All right, so that looks good. All right, and I think you can put stuff in here like really efficient matrix A. Put a new line in there. Close that. A. This is how Python's pretty easy to concatenate stuff. So just this will print out that, put a new line, print out the matrix, and put a new line. So that way when we put our B in here, load another array. And this one's just going to go. So you know what? Actually, before we do this, maybe I'll make just some variable square root of 2. And so this is where it's not as clean as MATLAB. You might be able to actually do it, but I know they have it's a square root function, and that NP just means that it's looking in NumPy and it's pulling a square root function out. So I'm going to call just that one square root of 2 and square root 3 is equal to NumPy, just because it's it's kind of long. It'll be messy to put that in this big matrix we're making. So, alright, so anyway, the first one was minus 125 divided by, so now I'll just use the variable we made up, square root of 2. Next one. Oh, we gotta do the, so this, even though it's to do a column, you get, you have to, you can't just do combo between them, you gotta make each one like its own row. So, next one was 300 divided by square root of 2 minus 25 times square root of 3 divided by square root of 2. Next row is 550. Divided by square root of 2. Next one was 950 square root of 2 minus 500 times square root of 3 divided by square root of 2. 500 divided by square root of 2. And 625 divided by, instead of 625 divided by square root of 2. And close the bracket and copy that. B, and let's see if it messed anything up. So it's not a symbolic, so it'll actually do the math on it. So if he did all the math if you converted everything to decimal, hopefully this lines up with what you have. And then the last thing we do is we can do the math. So just probably do it in the print statement. So answer vector. So now we have to do that inverse, and do matrix multiplication. So unfortunately, unlike MATLAB where you can just put like inverse or -1 and then multiply matrices, that's not how NumPy works. You want to multiply two matrices, so we want to multiply the inverse A times B. So first we got to call out matrix multiplication is the function, and then we want to call out the inverse. So that's linear algebra, np.linearalgebra.iv. And just remember that the np here is because we named it np. You'll see some programs will say import numpy as numpy or something else, and then that'll be what they have put in this beginning. But that linear algebra inverse will be there. So call that, and we want to put a into that. So that'll give us that, and then hit comma B. And so now this part is doing the inverse, and then this part is matrix multiplying that with B, and then now it should print that out. So let's hope this works. All right, so that was our matrix A, and answer vector should be that, and I'm not going to switch over because I don't know how, but take what we okay, yeah, I went back to the original page and looked at the answer. So the answer given was AX is 633, yep. AY minus 141, yep. BX minus 721, BZ, BZ 895, CY 200, and CZ minus 506. So you can see that's how you do it. So I just want to give you an example of that. I know you guys know how to do it by hand with substitution, but I want to kind of give you an idea of how you do this when you got big, ugly matrices, which you will have in your career. So this is how you do it, either MATLAB or one of these programs, or you could hand code it and see if you felt like it. But doing it with the matrices is the way to go. So hope you enjoyed this. Hope this was somewhat useful, and appreciate any feedback. Take care.